Let's start with the data fetcher, a component built to initiate data fetching. Notice how we use React's useState and useEffect hooks. We initiate data with a null state and create a cancellation flag. The fetchData_Async function then reaches out to the provided resource prop, a placeholder that represents an abstract way of accessing data. However, it only updates the state if the component hasn't unmounted, controlled by the cancelled flag. If no data is obtained yet, an error is thrown, which can be caught by surrounding error boundaries to provide a graceful UX. Next, we have the cache factory class. A simple JavaScript map acts as the storage system. We provide get and set methods to retrieve and store data respectively, keyed by a unique identifier. We can also clear the cache entirely, which is a practical operation, for example, when user sessions end. Here we're looking at the useServer data hook, which utilizes the cache factory to prevent redundant network requests. First, we check for data associated with a unique cache key. If it exists, we return it immediately. Otherwise, we execute the provided fetcher function, which should return a promise, then cache and return the result. This pattern allows React's concurrent features to suspend this hook while data is fetched on the server. Finally, we have the React component, which would typically live in a server.js file. This is a React server component where we call our useServer data hook with a simulated fetchData function and a unique cache key. The data is then ready to be used within your component's logic. Make sure your fetchData replacements and cache keys match your application's requirements. This architecture ensures minimal data transfer for optimal application performance.